Now we're recording. I hope you guys all approve. So, so we're doing continuous integration, right? Let me put that back up just because you guys saw the beginning of this, but the recording is just starting now. A continuous delivery, continuous integration as a way to build Mule applications, right? So this term continuous integration came from extreme programming, which there was this nice diagram that used to be on here about maybe well, anyway, the book was called Extreme Programming Explained, and I went and bought it because I wanted to learn what this process was that they followed. I had a copy of this in paperback. I think it's in my garage in a box right now. But anyway, this was a very thin little book, and it's a way to do software on a team. It's more than just Agile. It's like a very specialized kind of Agile. Um, and in this book, they identified a practice that fit with a bunch of other practices. So continuous integration was used by a single team who was as one team of people building software. Part of the assumption of CI/CD, part of the things it's good for, is that we're a team that's like a basketball team rather than a golf team. We're a team that works together and we all are doing the same thing. We're not all doing different things and trying to get our work to go at different times. We're all working on one thing together. And so we're trying to integrate our changes together into one thing, right? So back when they did the extreme programming team, it was at Chrysler. You can find it on c2.com wiki, Ward Cunningham's wiki. There was a team that made up extreme programming by trying it out on a project, and they all got in one room, and they had all the computers in one room, and they had all the tasks up on a board in one room. And whenever some couple of people were working on a task and they wanted to be done with it, you had to have a single central line of code because everybody's got different code on their computers, right? But you want to have one central one. So source control is a part of a continuous integration practice. I know it seems like it's like just this other, like everybody does source control. Well, not really. Everybody doesn't do source control. I've been at clients who don't have source control. So first thing you got to do is agree on where is the authority, where's the code that we all agree is the latest code. And you pick one spot for it and you put that in source control. That's social, isn't it? That's not enforced by anything. Like we all do that. We all pick a source control system and say that's where our code belongs. And we write our code in some of the same ways. So in Mule, we're using Anypoint Studio or Anypoint Code Builder. And we agree on a way that we set up our IDE, and we agree on a language we're going to use, and we agree on the steps that we're going to follow. That's what Francis was talking about at the beginning, of developers that we're not following the steps we're going to follow. Part of what you have to integrate is the way I work and the way you work and the way the next guy works so that they match up. Otherwise, we're not going to have a very good product, are we? Right? So the beginning of continuous integration is on the left side. It's the people who agree on some tools and agree on some practices on a team so that they can make a single product, a single thing that keeps getting better. And you have to work in some way to know what the requirements are and which one's more important than the last one. Scrum kind of does some of that. So somehow you agree on a way to know what to work on and to know, and this is where continuous integration servers come in, to know if the changes you made are any good. Because we have some minimum standards of quality, right? Now, sometimes it's unspoken, but the more you can make it explicit that we agree that we're going to have, only a system API talks to one system, or we're going to agree that we're going to put data weave in its own files, or we're going to agree that, I don't know, that we're going to stick to the latest version of a certain library or the second one back or something. You're going to have a whole bunch of those little choices you're going to make as a team that don't work if one guy does one thing and the other guy does another thing, does it? It requires us to do the same thing together, right? So one step is agreeing on what the rules are. And another step is checking if we're following the rules, because sometimes you can not know about the rules. So it'd be nice to be able to have somewhere to look and see what the rules are, right? And sometimes you can accidentally break the rules. Like, oops, I forgot to put my data weave in its own file. So I got to have some way to catch it, right? So that we can all, work more and more effectively at building a product that follows the rules that we've agreed on for our product. Now, the better we get at that, the faster we can add value to our software. The worse we are at that, the more churn, the more rework, the more trying again and starting over happens, right? Because Bob comes on the team and Bob doesn't know about half the rules. We tell him to add some feature, he adds the feature, but he doesn't follow any of the rules. Now we can't keep going, can we? We have to go fix Bob's changes. And it's kind of Bob's fault, but it's kind of our fault too on our team because we didn't enable him to work in our way. So continuous integration is owned by a team. It is the team's way of doing software work. Okay. Now we're going to look at some technology tools for that, right? Source control is one of them. Having some kind of CI server is another one, right? So you have a process that can look at your source control, and anytime somebody puts a change in there, it wakes up, it finds the change, it goes ahead and builds it and runs whatever processes we've made up to check it, and it has a pass fail inside. So we might stop right here. We might not keep going. If there's a change that doesn't follow all the rules, whatever the rules are, fail, red X, right? And we keep a history of that. Every time a change is made in our software, a good one gets a green, a bad one gets a red, and we can send an email to somebody. Back when we first started doing this, we had lava lamps. No kidding. It was kind of a trend in early Agile. You could set hardware devices up. I have one here. Nowadays, there's this cool company called Dynatrace. Let me show you this. I haven't got it hooked up right now, but I've got the hardware. This is a Dynatrace UFO. See that? It's a USB device, and it has red and green. These are colored LEDs, right? And I can make the build turn this thing red or green. I can hang it from the ceiling, right? And when the software is good, it turns green, and when the software is bad, it turns red. That's the kind of thing we used to do. So on that team, we had 2 lava lamps. Now, the reason that originally it was a lot of lava lamps and not one of these LED devices, lava lamps take time to warm up, right? So we had a red lava lamp and we had a green lava lamp. So if the green lava lamp was on, but it was not floating around, that means we just fixed the build, right? But then the longer the green lava lamp stayed on, the more that you could tell that it had been good for a long time, right? And when it goes red, the same thing. So we would turn the lava lamps green and red when we would pass and fail our build. That was a long time ago. In 2007, there weren't very many products to be CI servers. So we had continuous, it was called Cruise Control. It was a ThoughtWorks open source project we used back then. That was the first one I ever used. After that came Hudson, and Hudson turned into Jenkins, and now everybody thinks Jenkins is the old one. But Jenkins was the new fancy one back then. It was because it forked. Hudson was kind of, somebody did some bad stuff at Oracle when they took over the Hudson project, and Oracle relicensed it, so they redid it as Jenkins. And then a bunch of competition came out, and cloud vendors started making their own CI processes, and now there's GitHub Actions and Azure DevOps, which we're going to do today. And man, there's Travis CI and Circle CI, and you can find a lot of processes out there that'll host your continuous integration process that runs and watches your source control, and the good stuff goes in the artifact repository. What's nice about having an artifact repository is only good stuff goes in there. Like, you don't want to put bad code on the shelf, right? So you have a shelf, and Azure has one called Azure Artifacts, but you could also have one. JFrog makes one called Artifactory. Sonatype makes one called Nexus. You can think of like any place where you can put software binaries in a little database with version numbers on them. That's all an artifact repository is, right? It's nice to have some that work for more than just Mule, right? So a lot of times you're going to build a continuous integration pipeline. We call this whole cycle a pipeline that's for your software at your enterprise, not only for your Mule software. The left to right part of this diagram could be for all of your software. And, the more you can share some of the same tools, the more you can accomplish things like having security vulnerability checks with a tool called SNCC, or you could have reporting and monitoring and security on your software supply chain, right? So building a pipeline is something that makes sense at the enterprise software level, not only at the integration MuleSoft level. Yeah. Now, we can use very MuleSofty tools, or we can use very enterprisey tools for these things. But you're going to come up with some set of tools that your team's going to use to build a CI/CD pipeline. Some of those with any point in MuleSoft, you're kind of stuck with, and some of them you have choices, right? So obviously, if you're going to do deployments to any point, you're stuck with that part. You got to deploy to any point runtime manager. That's where they go, right? And then you can check and do manual testing and stuff inside your anypoint platform using that. So all the stuff on the top of my pipeline is kind of well, yeah, there's choices you can make, right? But as you get to the bottom, that's where you're going to have to use vendor tools. Now, I'm a little bit oversimplifying. Like when the actual build runs, you do have to use Maven. Anybody familiar with Apache Maven? Thumbs up. Maven itself is 22 years old. 23 years old? 23 years old. There's a place called Codehouse. It was an IRC server in like 2001. And before Maven, we had Ant. Anybody familiar with Ant? Now we're going somewhere, right? Put your thumbs up if you know what Apache Ant was. It was by Apache, but it was before Maven. We had Ant for many years. Ant has an interesting history. So Maven's better than Ant, and MuleSoft requires Maven. You have to use Maven. But anyway, Ant came before, and the reason Maven came to be is Ant is really flexible, like Make. You can make whatever scripts you want in Ant. So from project to project to project, you're making your build was like extra code you had to write. So Maven came along and said, we're just going to have a standard life cycle where it starts with build, or it starts with compile, and then we run tests. And then we're only going to make one thing per project. We're not going to have a build make 10 different things. One build makes one product. If you want to have two products, you have two separate Maven builds. Ant didn't have that constraint, right? So they created Maven, and Maven was the best, and it still is the standard, like for all programming languages. The others copy off of Maven. NPM for Node is made like in the image of Maven, right? The pip for Python comes off of Maven. It's built off of it. It's basically a re-implementation of Maven in Python. So Maven was the original one that was built that way. You make an artifact out of a project. It has a little XML file because it's so old. So the configuration file for Maven is an XML file. It goes in the root of your project. It's called pom.xml. Every MuleSoft project has to have one, and it defines the name of this project and and all of the different dependencies the project has. So software projects need to have libraries. Somehow we got to say which library this project needs, because maybe you're going to use the database connector in one project, but you're going to use the Salesforce connector in another project, and they don't both need both. So Maven says which ones you're having in your pom.xml. And then it had to find some plugins. MuleSoft had to make a whole bunch of plugins to extend what Maven does, because Maven is an open standard Java build tool, right? For specifically MuleSoft stuff. So the Maven plugin, that's what makes your Mule applications out of your source code. The munit plugin runs your test. The Exchange Maven plugin lets you, and the Exchange and extensions are for more advanced stuff that we might build, such as connectors or templates or things like that. Those are all done with the other Maven plugins. So you're, depending on the type of artifact that you're building, you would use various plugins that makes sense. And then MuleSoft's got this other very important component of the process called Anypoint Exchange. You're all probably super familiar with that. Exchange is a artifact repository, but MuleSoft calls it an asset repository because it's not only for software artifacts. It certainly is going to contain software artifacts. They're all related to the software development process, but there's a certain kinds of assets that are well supported in Exchange, and there's a nice user interface for searching for them and writing documentation and hooking up to the APIs and API manager. So it's very much value add on top of just an artifact repository. But at the bottom side, it certainly is a Maven artifact repository, just like any other one that you might get from JFrog or Sonatype, and you can put Maven artifacts in there. So that's probably what you're going to have to do now, based on some environments with MuleSoft, like for example, Cloud Hub 1, don't have to use Exchange for your Mule jars. Cloud Hub 2 does, but it kind of does it under the hood. And I just saw a spelling error that we're going to fix. I'm kind of anal about that. We're going to have to fix the spelling errors when we run across them. There we go. But the runtime fabric requires your Mule application to be in Anypoint Exchange in order for it to be deployed. So Exchange is going to be a destination at the right side of this diagram for your Mule applications. Part of the build is putting an artifact in Exchange. Now, you might also put an artifact in Azure Artifacts if you're using Azure DevOps, because you might want to have an artifact history that's owned by you. It's your own, it's not in the vendor's product. So based on how you're going to design your process, you might choose to add Azure Artifacts as an artifact repository as well. Because it can also have things that are not MuleSoft assets, right? When you put an artifact in Anypoint Exchange, I should probably pull something up here. I don't have Anypoint open. The group ID has to be your business group ID. It can't be com.mycompany.org or whatever. It has to be a big GUID, right? That's all it is. Let me see. Oh, I've got so much in. Let me just I'll just get this from my last class. But when you put stuff in Azure Artifacts, you can have any group ID you want, right? So you can put artifacts in there that are not necessarily MuleSoft artifacts, right? So like here's a service. This is a pom.xml, and you see how group ID says com.mycompany? You can't put that in Exchange. That won't go. You have to put your actual, so I'll put it like this, like my business group ID goes there. And then it'll go into Exchange just fine. So that's part of the translation process that has to happen with publishing to Anypoint Exchange. Now that's the continuous integration part, right? Where you build a product that's good, and now you've got a version of your software that exists. We call that release management. Every time you decide to put a version number on a release of your application, now you've got a new release. There's a good question what you're going to do with the release. Are you going to run that in prod right away? Maybe not, right? Continuous delivery is about the process you decide to have about what non-production environments are we going to make? What are we going to do in dev? What are we going to do in QA? What are we going to do in prod? Who's going to have access to the UAT environment? What data is going to be there? When are we going to snapshot it? All of that goes in continuous delivery. And part of what you're going to decide as a consequence of your business process for continuous delivery is how you deploy Mule software into those environments. Because it's a good question when you're going to deploy those versions. It might not be immediately. You might want approvals. You might want a change control record. You might, who knows, right? You might want to make sure that the version in staging matches the one that's in production for your integrations. It's up to you, right? Anyway, the tooling that you have to use when it's time to do promotions, you can use a Mule Maven plugin to do a deployment as a part of your build. And you can use the Anypoint command line interface to do a promotion separately from your build. So if you have a pipeline that's already got a release in your artifact repository, you can take that release and just put it in QA, put it in prod. And that's a kind of a maturity level for your deployment process to do binary deployments of versioned software artifacts. And so Anypoint CLI is how you would do those instead of the Maven plugin. Although you can do it with the Maven plugin, you just have to be real careful because you're rebuilding every time you're doing a deployment, which I prefer certainly to do binary deployments over build-driven deployments. Anypoint CLI is on version 4. You can install it with Node.js, and its learning curve is very short. You're not going to have a lot of trouble learning it. It's quick and easy. Documentation is pretty good. So if you're going to do these binary deployments, you have to have some way for the same binary program to be hooked up to different systems when it's in dev or when it's in QA or when it's in prod. That way you can point to a Salesforce sandbox when you're in QA, and you can point to the real thing when you're in prod, or when you're in dev, you can point to a local host or something. So you're going to put configurations in your application that can be sensitive to the environment that they are running in. So when the application runs, it receives its settings from the runtime environment and then points at the right things based on whether it's in dev or QA or prod. There's a few ways to do it. I'm not going to get too much into managing those property values today, but using them is a big part of your application design. You have two ways for the application to receive those values. One of them is property placeholders, and property placeholders picks up the settings at the time the application is started. And then the settings have to stay the same the whole time the application is running. So if you're using a database password that needs to be rotated, the application is going to still have the old value until it gets restarted. So anytime you provide a value in a property placeholder, that's going to be kept for the entire time the application is running until you reset it and restart the whole application. So it's going to have a come down and go back up. So if you want to provide properties that can change while the application is running, you have to use data weave expressions, and you have to have some code in the application to go get the value whenever it changes, or to refresh it whenever it changes. It's more complex to have properties load without the application needing a restart, but it's also kind of nice for availability. So if you rotate a database password, it just works and you don't have to restart anything. So those are both okay. They just have different consequences. You know, the top one is simpler. The bottom one doesn't require you to restart things. So those are two different ways to get your properties. Where they come from is possibly from just configuration properties connector, which that's built into MuleCore. It's right there in your Anypoint Studio. You can define the properties in the application, and then secure properties is how you can have encrypted properties in your application coming from the class path, and then they have to be inside the jar file for Cloud Hub. Now, if you're running on-prem, you can make the secure properties come from a file on the hard drive also if you want. But if you're in the cloud, you can't do that. You do have to have the encrypted values packaged inside the artifact, and then it can read the values at runtime and decrypt them. If you wanted to do something with cloud secrets, there are two MuleSoft connectors that allow you to use secrets managers: the Key Vault connector for Azure and the Secret Manager connector for AWS. And both of these can be used with HashiCorp Vault. It just takes some IT stuff to get that to work. So there's a few ways you can manage secrets. I actually have a whole study group just about secrets, but we're not going to do that now because that's a pretty deep topic. And this is just the continuous delivery part. Maybe it's not time to deliver it yet. Maybe we want a way to test our code, huh? Maybe we want a way not only to make sure the code builds and runs, but that it does the right thing. Right. So there's different kinds of tests that would go into your CI/CD workflow that you define as a team. Unit tests are the ones that are isolated. They run on just a tiny little bit of the code. Might be a data weave expression, might be a flow, might be one part of a flow. So really the idea of the unit test is I want to know if this exact code does what I expect it to do. And you can make those unit tests be manual. So I run them myself with Postman, or you can make automated unit tests with MUnit. And that's really what MUnit's for, is having a code-driven way of doing unit tests. And then your continuous integration process is going to include unit tests, and it's going to include functional tests. So functional tests make sure that the application works when it's running for real. So when I run functional tests, I have two kinds. I have functional tests that run as part of my Maven build, and those are going to require that, like, those are going to use real network protocols. And there's a functional testing framework from MUnit where you can have like a database start up on your machine and put a bunch of tables in there. So I like functional tests to use real things, but still in a way that I can control the data, right? And then you might also have functional tests that run in your dev environment to make sure that when you are sitting behind the dedicated load balancer, the application works with the certificates, things like that, right? Tie together a couple of different integrated components to make sure the application functions for real, right? Because you can have a bunch of units that work, but when you put them all together, they might not work, right? So I like to think of those as two separate categories of tests. And then we've got specialized tests for architectural stuff like performance and resilience. I'm going to leave those for the discussion part that's coming up. The way the study group, I have kind of a whole lesson I'm doing today, but I'm going to keep it short enough that we have time to talk about this stuff. So I'd like to talk a little more about unit tests. I am a fan of a method called test-driven development, but I'm not pushy about it if you want to do your test after development. But I do my Mule code with test-driven, which means I make an MUnit test before my code's done, and it's going to be read and it's going to fail. The test is not just a check that the code does the right thing. It's also a specification that tells us what the code's supposed to do. If you put unit tests in your code base with your application code, now you have two different things that have to match in your code. If you just have code with no unit tests, the information about what the code is supposed to do is not in the files, right? And so when I come back to the code 6 months later, how do I know if it's working or not? I don't know I don't know what the right input's supposed to be. I don't know when I run it what I'm supposed to look for to see if it's still working, right? So by putting unit tests in my code base, I'm leaving behind very specific, precise requirements for my code in the code itself. The nice thing about unit tests in Mule MUnit tests is they express the requirements of the code inside the source control system. And that's makes the asset a lot more valuable, right? So we're gonna use MUnit to do that. MUnit is a free language or framework. It's not really a language because it's in the same language as your Mule applications. You can run it in Anypoint Studio. You can run it in Anypoint Code Builder these days. You can't write MUnits in Anypoint Code Builder yet. So you can only edit in Anypoint Studio so far. I'm hoping by Dreamforce they change that. MUnits run with Maven. They produce file reports in the target directory that are compatible with Azure DevOps, so you can see the test results. So that way the tests that you run in your application are visible in the in the CI build as well. Okay. So I mentioned Anypoint CLI. This is kind of what it looks like, and that's where you can go get it. If you're the DevOps person or if you're responsible for DevOps, automating a lot of what you do in your CI/CD process is possible with the CLI. Not everything. Some things that you might want to do, like to update an API portal, is one I had to do. You have to use the APIs. So Anypoint Platform has APIs for lots of things that it does. So you can use those APIs to go do things that the CLI is not capable of if it's worth it. It is a little more effort, right? But it's certainly possible to do. So yeah, so I'm going to go on to Azure DevOps in a minute. But I've been talking a lot. So let me go back just to hear and any comments, questions, observations about what continuous integration is all about.
Hi, Ryan. Yeah, one of my issues has been properties and when they get injected. So things like one coding standards don't put hard code properties into your XML and your config files, have it as parameters and inject it. Secure them, and obviously the secure things need to be have a VM parameter. You need to have an injected security key because the secure property placeholder starts up early in the Mule runtime kickoff process. But Log4j, that's also an awkward one because the Log4j service starts before the secure properties process and starts before other parts of the Mule process. So you have to remember to do things like put sys : in front of some of your properties just to be able to make them available either from the operating system or the injected runtime. I think that's been one of my biggest issues, trying to get all those properties injected and get the layers. Yeah.
Tell me about sys. I don't know about sys.
It was in MuleSoft community Slack in the last few weeks. I had a Log4j file. I was trying to output data to Datadog, and an API key was hard coded into the Log4j. Obviously, I didn't want that in the repositories for all the applications, or people will be sending me funny logs.
Yeah.
So to be able to put that API key as a parameter into the Log4j, I had to put the parameter as sys : and the API key to be able to then put it as a runtime manager injected property.
Oh, and it would be available to Log4j if you did it.
It would be available for Log4j. If I put a runtime manager property called Datadog key, I couldn't just reference it as a property Datadog key. I'd have to reference it as sys : Datadog key.
Because Log4j is too early to find the ones that are not Cisco. That's
exactly. So there are different properties available at the operating system level, at the environment level, at the injected the runtime level, but then your different XML configs are going to call them at different stages. So just to be aware of the layers.
I'm glad you added that. I need to put that in my notes here, but so that's a plug for the MuleSoft Community Technical Questions channel. So if you're not in MuleSoft Community Slack, I can, Francis, if you have the link, whoever's in here can go fill out the form, and if you want to put it in the chat. Otherwise,
Right.
I can add that on LinkedIn or something.
Yeah.
But you found out about it on MuleSoft Community Slack.
Yeah, someone was just dealing with the same problem that I was at the same time.
But is there a documentation for that, or it's just you have to know the right people?
No, you just have to know the right people, or you have to know stuff outside of MuleSoft.
That's
Your
great.
language.
Well, everyone here knows the right person now. It's Francis. Yeah, that's cool. No, that's a good tip. That sounds like it would make a good blog.
But there's other awkwardness as well that ties in with your continuous integration. I've been updating connectors and using a parent POM, the Mule, oh God, I think the Mule module parent, the Mule, which is for doing your connectors.
Uh-huh.
And what I found is that they don't tend to be backwardly compatible. So when you're updating your MuleSoft connectors, you know that they work with Java 8 and Java 17 when the documentation says so. You know that they work with different Mule runtimes. But I've been finding the Mule module parent POM, which is what you use to compile and deploy your connectors, they don't always tend to be backwardly compatible. So when you try and run something that you use the Mule module parent 1.7.2, it seems to only work with Edge release 4.7.2 of the Mule runtime and won't let you run it in Mule 4.6.6.
I had that same, so I'm building a connector, and I had that same, I had to guess a bunch of parents until I found the right parent. I think I ended up on 1.3.2 that consistently worked for me.
1.3.2 does consistently work, but I've tried 1.6.0 because that's what the documentation said you should use for anything
Oh
that's
yeah.
going forward for Mule 4.6. But I found that lots of release candidates, 1.6.2, 1.6 release candidate one, various versions of 1.6 just didn't deploy, didn't work. 1.7.2 released on August 1st does work, but it's only available, it only allows you to use it on the latest version of Mule runtime.
I'm okay
So,
with that actually. I found with 1.3.2, I had to guess a lot of MUnit plugin versions, and I left a comment. I found it in a Mule help here. So to get mine to work with Java 17, this was you're looking at the configuration that worked for me. This does work on Java 17, but I wouldn't mind using the latest one, 1.7. I would try it out. I don't,
that,
that's a good tip. Is
that only came out 3
1.7.2.
weeks ago. So, yeah, go for it.
Yeah, but I have to abandon 4.6.
Yeah, yeah. And that's a problem for me because I was going to use the long term support version and I was just more disappointed that they weren't backwards compatible.
Yeah. Yeah, I've been very disappointed with connector development is still not be good for you have to get good at it. You have to learn all these little tricks of the trade that are not exactly like the documentation for sure. That's the
Yeah.
extensions Maven plugin that builds those. Good tip there. So yeah, that's building connectors for those. So for those who are newer to building stuff in Mule, what Francis is talking about is you can make these in your Mule palette. Now you don't have to do that often. Probably what 5% of customers end up making their own connectors, maybe. I don't know, not that many. But if you need to, you have to do it in Java, and there's two. There's an XML connector SDK, and there's a Java connector SDK. And we were just talking about the Maven build for the Java SDK. Very cool. Well, you guys want to talk more Maven and stuff, or you want to do some Azure DevOps? I just figured I would specialize on one of them. We could do this again, all over again for GitHub Actions. We could do this all over again um, for Travis or Circle or Jenkins. I figured it'd be nice. The one I was working with recently was Azure DevOps, so I figured I could make a study group around it. This is the way Azure DevOps does continuous integration. First of all, Azure DevOps is a set of software development tools, not only CI tools. So it's its own product. It's not exactly part of Azure. You can kind of make an org for yourself in Azure, but it's a different website. The logins are different. It feels pretty separate from Microsoft Azure. You do use a Microsoft account to access it, and so does the rest of your team. And you don't have to use all of it. You can pick and choose. which parts of Azure DevOps you're going to use. So the boards, this is for managing your tasks and work items, and you can actually make a graphical board where you drag cards from column to column, and you keep a history on what you're working on, right? So it's kind of about managing the work that the team works on, right? There's a GitHub kind of competitor, Azure Repos. Although I don't think you can make many of them, but that you can make source control repositories hosted in Azure DevOps as well. And all of these tools do work pretty well. You don't have to tie them together. You can, but it's not. It doesn't make it weird if you try to use one with the other. Yeah, go ahead. Oh, no, okay. And then so Azure Pipelines, that's the one that does CI pipelines, that watches your source control and does your builds and stuff like that. Now there's we're going to dig more into Azure Pipelines. There's a test plans thing for managing your QA process. It does manual and QA and automated testing for the quality assurance people. And then there's an artifacts repository component of it, which isn't only obviously for MuleSoft. So those are the different components. When as far as I can tell, you don't, like, some of them have extra costs associated with them, but just having an Azure DevOps project allows you to have access to all of them. Or it's not like you have to pay extra to have each one, unless you start using it a lot. There is some consumption-based pricing. So we're going to talk a little bit about the pipelines. A pipeline is a definition of a continuous integration, continuous delivery process. Now there's build pipelines. I don't know if I have a slide for that. Let me look. There's build pipelines and there's release pipelines. Release pipelines are kind of legacy, and there's no way to drive them with code. Okay. A build pipeline is now doing everything that, so the old version of, like, long ago in Azure DevOps, you used to have two different pipelines that would hook up to each other. Now a build pipeline can do all the jobs that release pipelines can also do, including approvals and deployments. So I can show you some code for these things. You can configure a pipeline directly in Azure DevOps with a point and click, kind of a low code configuration, although it's not going to stay low code. When you start designing these steps, it's back to pro code again. You got to write bash scripts, or so I'm going to show you around my my Azure DevOps environment. I guess that'll probably be a good way to see some of the things you do with it. The pipelines run on these things called build agents, and those agents can be cloud provider, or you can have your own. So I'm just going to go to dev.azure.com. I have like a few different accounts in here. I'll do the one. This isn't the one that's got the best stuff to show you guys, isn't running Mule stuff in it. So I'm actually going to show you a pipeline I built for a .NET stack, just because I'm using more of the different Azure DevOps features there. Let me see if I can get it to go in here properly. There we go. Why does it keep doing that? Oh, it keeps forwarding me to the wrong place. /beyond. There it is, beyond. So this is like a preview. Look, you can look into the back end. We're building a little product for Integration Quest that lets you kind of set up your own infrastructure for running integration, like learning integration stuff. So this is it. I'll show you. So this is Azure DevOps. I'm signed in. Let me just take you to the top level. In Azure DevOps, you have multiple projects, right? You can even have multiple organizations. So the organization is what the money is attached to. This is what you pay for. And this is also where you manage top level security and this thing called agent pools, which I'm using. So you can have build agents that run on your own infrastructure instead of just inside Azure DevOps. This is also where you manage repositories and artifact storage. So you have organization level settings for Azure DevOps, and then you create projects. And then inside the project, you can set up more than one board. So we have a couple of boards. You can set up sprints and backlogs. So that's all the board section where you manage like your work, right? You can set up repos, but I'm using GitHub, so you're not going to see anything in the repos section for my product. You can set up pipelines. So these are pipelines. Pipelines can be organized. I didn't do mine, but you can organize them in folders if you have a lot of projects. Let me pick one like let me do the secret API here. No, that's old. Let me get one that's actually had changes recently. This one's actually got a failed build, so I don't mind showing you this. If you hit edit, you're gonna get in my case, you're gonna get this YAML file to see the design of the build. When you make a new pipeline, you don't have to do it in YAML. So when you can do let me go back and make a new one and show you what that looks like. You can just make a new pipeline yourself and hook it up to wherever your code is. So here's GitHub, and it'll have my credentials and a bunch of that stuff. Let me use like I've got a lot of code in here. Yeah. I want to do something muley. Um, let's go. This one's mule. There we go. So I'll just say yes for now since I'm on the video anyway. Do my two-factor stuff. So Azure Pipelines is getting access to my GitHub. Where is it? Oh, this is my GitHub one, right? I have so many codes on here. Two-factor has gotten crazy these days. I have 3 different authenticators on my phone, and they're all full of many things. I want to go back here. Going back to Azure DevOps. All right, so now I can like tell it how I want to build my pipeline. And then it gives you some templates and stuff. So I could just do one of these templates and it'll kind of template it out for me. And it gives me a way to like make a pipeline that runs Maven all by itself. So it gets you started kind of quick and easy. I'm not going to run that one though, because it's going to fail. So let's go look at one that's already running. Let's do this one here. You see that we started having 2 stages. That's what these little circles are under stages. So each stage can have a success criteria, and then you can tie approvals to stages. So if a build makes it up to the QA stage, I could have environments defined. I don't think I did any in this account. I have another account with environments. Environments are how you make, let me just do one real quick. Let's do a staging environment, right? And we're going to make the staging environment have approvals, right? So I can say that if something's going to deploy to my staging environment, I need to make sure that, let me put Diane Kessler in here as an approver for my staging environment, right? And now for anything to deploy there, she's going to have to say yes, right, for the staging environment. So you can tie pipeline stages to environments, and then when it's time to go to that next stage, it'll wait for somebody to approve before it goes. So it kind of gives you a way to have users control the promotions of your software from environment to environment by creating these stages. And then what a stage does is it defines a series of jobs and tasks, right? So I think, let me go back, see if I can get my vocabulary right here. I'll hit edit on here. I believe jobs, yeah. A stage has multiple jobs, but I only have one here. And then the job has steps, and the steps have to be a particular task type. So over here are all these task types. I'm using a lot of shell scripts, but as you can see, there's so many task types that know how to do various things with your build, right? So you and then you can carry state forward from step to step with variables. So if something passes one step, you can get like a token and then inject the token in a later step so that then that information can be used in the build. And that's really all it is to make a build in Azure DevOps. And then every time you commit code to your source code repository, it's going to run for you one of these pipelines. So I guess the last thing to show, I will show the release pipelines. As you can see, I'm not using them. It's not something you need to learn because it's there for legacy reasons. It used to be that to do the deployments, we would use release pipelines and approvals. And now if you go read the Microsoft documentation, they don't recommend separating release pipelines. They just recommend doing everything in build pipelines. So this is kind of the Microsoft backwards compatibility thing. There's this section in library called variable groups. If you're going to do promotions to higher environments, you're going to need secure credentials and stuff. So you use variable groups for that. You can make a variable group that has dev values and QA values and prod values, and then you can secure who can access each one of those variable groups. That way, not everybody on your team has the production passwords, right? So that's where you would do that. And then finally, Azure Artifacts. This is where you can have the artifacts published. I think I am using it. Yeah, I'm using Azure Artifacts in this case because we're publishing .NET DLLs for use in NuGet. So Artifacts, this can be just like Exchange can be. This can be a Maven repository if you want to publish your own artifacts that way. So yeah, so there's my little Azure DevOps tour. Happy to do questions about that too. But yeah, any questions or anybody using Azure DevOps now?
We're using a little bit and wanting to configure it more, so that's why we kind of wanted to see this.
You're using which part of it?
We have a board right now, and then we use the code repository, and we're wanting to get CI/CD in.
Yeah, you're going to start with pipelines.
Yep.
Cool. Awesome. Well, I encourage you to just plunge in. Do you have on-prem stuff or is it all cloud?
It is on-prem.
Yeah, so you might need to do, I guess I could show you a little, it's a little more Azure, but for on-prem stuff, I had to do quite a bit of surprisingly difficult stuff. Well, it took me a minute to get this agent pool working. So I needed stuff to run inside my network and to have tools already assigned on the VMs, like installed. So I had to make agents. And this agent pool is connected to, there it is. It's a VM scale set. So if you're out of the box, it uses cloud agents that Azure Pipelines provides that are just running on the public internet. That doesn't do me any good on my private network. So I made a VM scale set so that it could scale down to 0 and I don't pay money when I'm not running builds, but then it'll scale up and make images. So I had to learn all this Azure stuff to make a scale set where the agents would have my image on them with my tools, because I had to have Terraform and Anypoint CLI and all these little command line tools installed on the Linux machine. And so I had to make this all this Azure stuff so that it would do that. In particular, it's not just setting up a scale set. It was an image. I had to make the image that was running on the scale set in a gallery. So there's all this. Where's the? I think that's here. Is it the operating system one? Yeah, there's an image reference here. So in order to get that whole pipeline work, I had to generalize my, basically you take the image, you make a VM, you update the VM with all your installers on it and everything you want, and update all the security patches, of course. And then you have to turn it off and generalize the OS so it erases your login and everything from it. And then you can, and it's a one-way action. Once you've generalized it, that machine is done forever. And then you can publish that image to a gallery. That's what was required. That was all the stuff. I ended up reading documentation for a whole weekend to figure this part out. So there's my CI/CD gallery. We just had to update the image like over a year later. I had to learn about it. So there's my because this one I had to put some Kubernetes tools on there. So my latest version we just did last month. After a year, I used the same image for a year. So when you do on-prem stuff, you're going to have to hook up a VPC and a virtual network and a VPN and then make these. It's a whole bunch of system administration stuff for on-prem. But hey, that's what it takes in Azure. It hooks up really nicely to the agent pool though, because then it runs my jobs on my machines instead of on their machines. So, there's this other whole part you're going to have to read about called service connections, which provides the credentials when a job needs to go do something somewhere in Microsoft Azure or GitHub. It like has to have a login. So you see right there, I just added a service connection in front of you guys. There's my GitHub connection. So that's like another part of the settings for the project is all the logins it has to have to various things. So anyway, yeah, that was the on-prem version is a little more complicated, but it's certainly powerful. It certainly does what you would like it to do. So, all right, well, that was my Azure DevOps stuff. We are at an hour, so we can shift out of like lesson mode into more like social hour if you guys want. Then anybody have another favorite? You like something better than Azure DevOps? Come on, at least one Jenkins fan has got to be here. Right?
No, I'm GitHub. GitHub
GitHub
Actions.
Yeah. GitHub Actions are all JavaScript, right? I think.
You're more of a DevOps man than I am.
No, well, I don't know for sure. I would have to. I tried to do one build with GitHub Actions, and I've tried Travis CI on GitHub also for my Speedway project, and it failed. I haven't got it working yet. Being a DevOps guy is a perseverance test.
Absolutely. And I'm spending my time just trying to get standardizations before I start doing my CI/CD again.
Yeah. Yeah. Well, I guess I can stop the recording. Goodbye, everybody on the recording. Stop.